Okay, so welcome to the last class. So I thought that because this is the towards the end, you are already loaded with so many things. Let us we will do only one scheme of digital signatures, and after that we can start the quiz. Right? There will be only one question. So you make sure that you have papers to write the quiz. Right? So just because I know that some people do just come like that, without any paper, pen. There will be a problem, right? So. Uh, Now, this digital signatures is a very interesting topic and very commonly used, plenty of applications. Now, when we say digital signatures, what do you mean by digital signatures, right? So, if we look at normal, so suppose you are signing some document, right? So you can sign with your pen and paper, right? With a pen on a paper. But in case of digital signatures, this problem becomes a little bit non-trivial, right? I mean, how do we? So one way, I'm sure you know that in Adobe Professional, you can do the signatures and so on. But uh, for the systems to match, actually, or verification, it should be computerized. So in order to do that, uh, any digital signature scheme is divided into two components. One is signing algorithm. There should be signing algorithm, and second, there should be verification algorithm. Signing algorithm is usually a private system, right? Private algorithm, and verification algorithm is public. So anybody can verify the signature. Okay, this guy has done the signature. Okay, on this document, right? So I will give you just brief sketch overview how this digital signature works, and after that I'll give you one RSA signature scheme based on RSA crypto system, right? That kind of signature scheme, and that's all. Uh, though in the notes I have written Elgamal crypto system scheme as well, but I'm not going to discuss. You can look at it. Normally people cover these two as a basic one. Uh, since you know elliptic curve, you can actually even go for higher signature schemes, and you can read on your own. Because now you have some basics actually. Okay, so let me start with digital signatures. Signature schemes. There are two components: signing algorithm and verification algorithm. Okay, so signing algorithm, I'll denote it by SIG. It's a function. It's a private function. X is a message. Normally, that is what we have been assuming. And verification algorithm is VRK, work K, and this is a public one. Now, this signing algorithm depends on a private key. Okay, call it as K. That's why there is a sign K. Okay. So, given a pair X comma Y, X is your message, and Y is signature on X. So, how do you define signature on X? So, basically, Y is signature on X. Okay, using signing algorithm, right? So we are signing, right? So basically, our verification algorithm. So normally we transmit this message X and signature Y, which is function of X, right? We transmit this thing, and somebody who wants to verify, what they will do, they will actually apply this function on X comma Y. If this is true, so this is true if y is this, and this is false if y is not equal to signature of x, right? So this is obvious that once we receive this pair, so anybody can receive this pair x comma y. X is a message, y is a signature, right? So you just check whether it is signed by, whether this, if this relationship holds, that means it is a signature, right? Of course, now there are different ways you can force a signature. All kind of challenges are there, which I'm going to discuss few of them. But this is the general scenario. You take a message x, apply a signing algorithm, get a signature y, take the pair x comma y and transmit that pair x comma y, right, to the third person. Somebody who is receiving x comma y, he will use the verification algorithm, which is a public algorithm, and that algorithm will, the job of that algorithm is just to check that y is signature of x or not, right? Okay, that function it will verify, that's all. So formally, this is a general scenario, but formally what we do, a signature scheme consisting of P, a finite set of possible messages, A, finite set of possible signatures, okay, K, actually it's a key space, again finite set of possible keys. Okay, so basically signature scheme we define. So in general we have, it's a 5 tuple system, P, A, K, S and V. So P I talked about, A I talked about, K I talked about. What is S and V, you know? So for every K in this bigger K key space, there is a signing algorithm in S, okay, and a corresponding verification algorithm. Okay, signing algorithm and verification algorithm. So basically, I should say that function from B to A, signing algorithm and verification algorithm, function from P cross A to true or false. Okay, such that for every X in P and for every message X in the message space and for every signature Y in A, okay, set of possible signatures, verification algorithm when acting on the pair X comma Y is true if Y is signature of X and false if Y is not signature of X. Okay. So a pair X comma Y where X belongs to P and Y belongs to A is known as a signed message. Okay. So as I mentioned earlier, so mathematically we can define like this. So basically now signing algorithm, verification algorithm, and this pair is there where X is a message and Y is the signature. Okay. So the pair X comma Y is known as signed message. So let me give you example of RSA signature scheme. Okay, N is a product of prime numbers. P and Q are primes. Our space P and A both are integer modulo n. So message is coming from integer modulo n and signature is coming from integer modulo n. Fine. K is the tuple n P Q A comma B such that n is equal to P into Q and product A B is congruent to 1 mod phi n. Phi n is the Euler-Torsion function, right? So here the value n and b are public key and P, Q and A. P, Q and A are private key. So I should give you the signing algorithm and the verification algorithm, right? So for K is equal to N comma P comma Q comma A comma B, we define signing algorithm. Our signing function is x raised to power A mod N. And verification algorithm is x comma y. So this is true if and only if x is congruent to y raised to power b mod n. Here x and y belongs to integer mod. So basically you can see that Alice signs a message x using RSA decryption function dk. Okay. Alice is the only person which can create the signature. So because this is a private thing, and this verification is a public thing. Okay. And the encryption rule of RSA crypto system is used for verification. I think anyway, that's all. I mean, of course, we can discuss some crypto analysis and so on. Probably I will leave that because I think time is not there. I need you require some time to do the calculations anyway. So I'll stop here, and so you can take one page out, and we can have the quiz, right? So just make sure that you write down your name and roll number on the sheet, right? Whatever sheet you have taken. I hope everybody is having pen and paper. And अरे काउंट किया था कितने कितने स्टूडेंट्स है टोटल? हाँ 120 प्लस. तो आप लोअर बाउंड दे रहे हो, करेक्ट वैल्यू नहीं मालूम. Anyway, so up to what time you want to finish the quiz? 9:30 or 9:45? Because when I write a question, depending upon time, we may vary the length. Anyway, Find all points on the elliptic curve over Galois field having 25 number of elements, and the curve is y square is equal to x cube plus x plus 4. What? This is the question. You have to find all points. How many points are there? Now, some of you may be remembering field with 25 number of elements you have never constructed, right? So you have to find a polynomial, do all those calculations, and then. So if you want, I can help you by writing the polynomial, or you want to do it yourself. पॉलिनोमियल दे दे तो आसान पड़ेगा, तो फिर बचेगा क्या? थोड़ा सा इंटरेस्टिंग है ना. 5 स्क्वायर पॉलिनोमियल निकालते ही निकालते आधा घंटा निकल जाएगा, राइट? आई नो. एनीवे, ठीक है, आई कैन हेल्प यू लिटिल बिट. I have written the polynomial x square plus 4x plus 2. X square plus 4x plus 2. Let me end this session here.